Welcome back to the Digital Fluency video series, The Story of Data. As always, for maximum benefit, we suggest watching this video in full screen. So far, we've been talking about structured data, like numbers, letters, and special characters, all arranged in rows and columns of a relational database. These days, there is an ever-increasing need to be able to store and process unstructured data, like images, audio, video, word processing files, spreadsheets, and health records, not to mention data generated by things, the Internet of Things. And then there is semi-structured data, which is a form of structured data that does not obey the tabular structure of data models associated with relational databases. It does, however, contain tags or other markers to separate elements and enforce hierarchies of records and fields within that data. Some examples of semi-structured data sources are emails, XML, and other markup languages, binary executables, TCP/IP packets, zip files, and web pages. It all started with the digitization of movies, videos, music, and photos. The list has grown to include the Internet of Things, smart devices, imaging, GPS data, documents, sensors, health records, and more. Files that contain unstructured data typically contain metadata to help identify it. You may recall that metadata is data about data. For instance, video clips contain metadata that contains the resolution, speed, and frame rate of the video. Audio clips and music files contain metadata like bitrate, artist, genre, and title. GIF, JPEG, and PNG images contain metadata like resolution, size, aperture, shutter speed, and ISO number. And DICOM images contain metadata including patient, doctor, study, series, and instance. Semi-structured data usually contains tags to identify groupings and order to the data. As an example, XML files have opening and closing tags. In this example, you can see the opening and closing airport tags, which tell us what this file is all about. Each row identifies an airport by specifying its city and abbreviation. So we can't use a relational database to store unstructured and semi-structured data because it doesn't have text data that can be related. So for that, we use a data lake. I think that it's called a data lake because you can throw just about anything into it, or at least any kind of data. So semi and unstructured data get stored in what we call object storage. Object storage is just a bunch of disk space wherein we can store any data object, no matter what it is. In other words, there will be just a bunch of files sitting there in object storage, much like files you might have in a folder on your PC. The metadata also gets extracted and stored in a relational database called a data catalog. The data catalog can now be searched to see which files match what you're looking for. For example, say you're looking for a movie or a song with a specific title. The search results would give you the name of the file in object storage, which you can then retrieve from there. So in a sense, the data catalog is your index into what's available in object storage. The architecture of a data lake starts off by specifying our semi-structured and unstructured data sources. There are many, including binary files, audio and video files, device logs, IoT sensors, XML, and email. This data is then brought into the staging area, which is just object storage. It will sit there until it is cataloged and processed for permanent storage. The data is then subjected to a data prep, validation, and transformation process, which basically means that the file is copied into the data lake's object storage, and its metadata is extracted and written to the data catalog, along with the file name and its location in object storage. We then add an application program interface layer, through which analytics and visualization software like Power BI and Dynamics can access the data lake. There are other types of interfaces, but you get the idea. Now the consumers can have at it and do their thing with the data in the data lake. To manage structured, semi-structured, and unstructured data together, we take the data lake architecture, merge it with the data warehouse architecture, and create a data lakehouse. This gives us the best of both worlds. That merged architecture shows that our data sources can be structured, semi-structured, or unstructured data. In the staging area, the object storage will hold all three data types until they are onboarded. The structured data will then undergo the ETL process and be written into the data lakehouse relational database. Entries will also be entered into the data catalog so that consumers can know what's available. All other data will be processed and stored in the lakehouse object storage. The metadata will be extracted and written to the data catalog. Summary data and data marts will be created and recreated as necessary when new data arrives. The data lakehouse will also be kept in sync with data from the ongoing operational databases. The consumers can now consume the structured, semi-structured, and unstructured data via the API, or directly by using structured query language, which we usually just call SQL. By the way, SQL is a topic of one of our other Data Fluency videos. Let's look back at the topics we've covered. In Scene 1, we defined data and information, then introduced you to structured, semi-structured, and unstructured data. In Scene 2, we talked about how structured data is stored, both manually and in a computer. Then we presented what a database looks like in terms of tables, columns, and fields. We also discussed the use of key fields, with which you can create relationships between the tables. In Scene 4, you learned that we like to archive all databases in a data warehouse so that you can cross-reference all of the data in support of business intelligence. Next, you learned that data is what we store and information is what we generate from that data. However, when it comes to data warehouses, we do store information so that the consumer does not have to wait for the information to be generated and thus can get it faster. You can, however, still get at the original data in the data warehouse because that is stored there also. Scene 6 explained that unstructured and semi-structured data can't be stored in a database because that data can't be searched, nor does it have key fields with which we can relate the data. Scene 7 introduced you to data lakes, which is what we use to store unstructured and semi-structured data. Finally, we showed you how all types of data can be stored together by combining data warehouses with data lakes into what is known as a data lakehouse. You may have heard the term big data and wondered what that is all about. Well, it has nothing to do with font sizes. It's all about ways to analyze, systematically extract information from, or otherwise deal with data sets that are too large or complex to be dealt with by traditional data processing application software. For example, monitoring health conditions through data from wearables, live road mapping for autonomous vehicles, personalized health plans for cancer patients, data from stock exchanges and social media sites, and jet engines. Did you know that a single jet engine can generate 10 or more terabytes of data in 30 minutes of flight time? With many thousands of flights per day, generation of data reaches up to many petabytes. Now that's a lot of data. Big data is a fascinating subject and is the focus of one of our other videos. I sincerely hope that you found this video useful and that it helps to fulfill my mission to provide a baseline of data and cloud fluency for non-IT persons. So please take the time to give me some feedback. Tell me what you liked and what you didn't like. What else or changes to this topic would you suggest? Please visit sandbox.fluency.com sandbox.it-stuff.guru and let me know. Currently, the digital fluency videos include the Cloud series and the Data series. As you can see, the list is quite extensive. Please visit sandbox.it-stuff.guru where you can browse the video catalog and view any of these videos. Once again, my mission is to create a baseline of data and cloud fluency for non-IT persons. To help me fulfill this mission as it relates to you, what additional videos would you suggest? Please visit sandbox.it-stuff.guru where you can provide me with your suggestions. That's all, folks.